Hey everybody, this is Bharat Muthuswamy.
And Amir Muqtaderi. This lab demo will show you how to boost an input voltage. In this lab demo, we will design and test a power supply known as a boost converter. The boost converter power supply exploits the properties of inductors, transistors, capacitors, and diodes in order to boost the input voltage to a higher value. For example, given a supply of 3 volts using these circuit components, we can produce a larger voltage source, such as 10 volts, by choosing appropriate values for the circuit components. Note that unlike an operational amplifier that amplifies voltages, the boost converter requires a much smaller area to realize and is ideal in applications that require high operating voltages such as microelectromechanical systems or MEMS. The fundamental idea behind the boost converter is the 2 states. One when the transistor is on and the other when it is off. When the transistor is on, it acts like a short circuit. Hence, the boost converter is a voltage source in series with the inductor L. Since current through an inductor cannot change instantaneously, the circuit does not immediately spike up to an infinite current, and thus builds up current.
Okay, so I'll be doing the lab demo and discuss the off state of the transistor. Okay, here is the boost converter. So basically, it's a pretty simple circuit. The only thing is the transistor might get hot, so please don't touch it while it's working. So let's look at the input. So the input is 5 volt. It's only consuming around 47 mil. But if you look at the output, it's boosted up to 30 volts. So basically, when the transistor is off, it acts like an open circuit, and hence the inductor now sees a voltage source, capacitor, and load resistor. Here we're using a 59K load resistor, I believe. But the bottom line is, since the current through an inductor still cannot change instantaneously, the initial current flows through the load resistor. Since V equals IR, the voltage of the output increases. The bypass capacitor is to make sure that the boosted voltage to the load provide the boosted voltage to the load resistance when the transistor is on, because the transistor is a short circuit when it's on. The diode is to prevent any back current from affecting the inductor. That's it for the lab demo. Okay, now that we're done with the lab demo, we have come to the final, quote-unquote, lab in the course, which is the final EEG project. We will see you then.